Over 95% of customers are willing to take this product. There's no need for that. Hey, President Zhang.
Hey, President Su. Hello, 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 hello. Hello, hello. Hey,
And this is our...
Hello, hello, hello.
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 This project here is one we developed ourselves.
Mm.
We do our own development and construction, and we are in new materials and advertising.
Ads, R&D, and building.
Right.
We summarize the future of construction into two main directions. The first is the industrialization and prefabrication of methods, my current focus. The second is the environmental friendliness of materials through solid waste utilization. Combining these helps control carbon emissions and is the most effective approach. This company has innovative R&D in solid waste use, like this silicon crystal sintered panel, which is primarily used for both interior and exterior partition walls. Currently, the mainstream interior wall product on the market is the ALC wall panel. However, this type of product has a few issues. First, they are prone to cracking. ALC wall panels can deform due to factors such as drying shrinkage and temperature changes, which then leads to cracks in the wall. Another issue is they tend to absorb moisture due to high porosity. This causes high water absorption, so ALC panels are seldom used for exterior walls where crack control is stringent. In contrast, silicon crystal stone panels effectively solve this. They are made from crushed solid waste and mining raw materials, then mixed with a key formula of microscaling agents. This process requires vacuum extrusion. Finally, the material is sintered at 90 degrees, resulting in silicon crystal stone panels with stable properties, moisture under 12% and shrinkage below 0.6. This means that the joints between panels do not require complex treatment to prevent cracking or seepage, making them suitable for both interior and exterior walls. Another very crucial point is that 70 to 80% of the raw materials are solid waste others pay to dispose of. Moreover, they adapt to local conditions by using local high-yield solid waste as raw material. Consequently, production costs are lower, making the price more competitive than ALC panels. The cavity structure can hold insulating materials, further enhancing performance once combined. In my view, its only disadvantage versus ALC is higher density. Installing ALC panels is already labor-intensive. But if this wall panel still requires manual installation, it would be completely unfeasible. To solve this, they developed a solution. Their installation robot, now in its 4th generation, is compact and highly flexible, taking only 4 or 5 minutes to install a panel. This reduces the need for manual labor while significantly boosting efficiency. Of course, this is just one of their many research and development achievements. They also have patented lightweight prefabricated staircases and exterior decorative cladding panels. If there's an opportunity later, I'll give you a more detailed introduction to these products.